Lesson 73, we're going to talk about applying trigonometry with angles of elevation and angles of depression. And this is going to come in a lot. They're going to give you a lot of word problems that involve this. So we start off here with angle of elevation. Angle of elevation is the angle formed by a horizontal line and a line of sight to a point above. And I'm going to give you an illustration here of this, and I know you can't see this on the video, but you know, if my line of sight as I'm standing here goes straight out from here, and so I have a horizontal line that's parallel with the ground, that is my line of sight. Does that make sense? All right, you have a line of sight as you're standing that runs parallel to the ground. Your angle of elevation occurs with that line of sight as you look up at something. So there's an angle between my horizontal line of sight and the angle that goes up as I look at the light back there. This angle right here between my hands, right, that's called the angle of elevation, okay? And essentially what that forms is a right triangle, okay, with this right here. This is my line of sight, that's my angle of elevation. Does that make sense? Okay? Most questions that are going to involve angle of elevation are going to be somebody looking up to the top of a tower, somebody, you know, looking, you know, we had a question a while back and it didn't necessarily refer to angle of elevation, but it would count, like let's say you're at Cape Canaveral watching a rocket take off, right? The camera on the ground has a line of sight that's parallel to the ground, and as it's looking up, it's forming an angle of elevation. It's looking up. Does that make sense? All right, now angle of depression is the angle formed by a horizontal line and a line of sight to a point below. So the same kind of thing. I have a line of sight that runs parallel to the ground, and if I'm looking at, you know, there's like a big old flunk of hair there on the ground, all right? From here, I'm looking down, all right? So what I've got is now I've got my right triangle, except it's down, all right? So my angle of my line of sight is still parallel to the ground, but now I'm dropping down and I have an angle of depression. I'm coming from that line of sight down, so it's depressed, okay, versus elevated, okay? Most questions that involve angle of depression are going to include, say, an airline pilot in an airplane looking down at an airstrip. That's angle of depression. All right, a bird of prey looking at a cat on the ground that it's going to attack and maul and kill. All right, it's my goal as a math teacher to kill as many cats as I can in my word problems. Okay, so typically I'll take a word problem, and if it involves something, I'll convert it over to the death of a cat in some way or form. If that offends you, let's get over it. Okay. All right. This is a picture, and this is the differences. All right, we've got, and I did my best to draw a couple of these figures. Here's my airplane up here. That he has a line of sight that's running across, right? As he's looking down at something, that's forming an angle of depression. Okay, this is the right triangle that we want to draw in order to find what we need to find. Okay, does that make sense? So whenever we talk about angle of depression, typically it's going to be our right triangle upside down. Okay, now if I've got a man on the ground and he's looking up, we get our pretty typical right triangle here. Okay, we get the difference. I hope so, because if we don't understand, if we get angle of depression and angle of elevation flip-flopped, we're going to end up getting a lot of these questions wrong, right? We're going to do the exact wrong thing. So from here we use trigonomic functions to solve unknown lengths and angles, and a lot of it can still be confusing because of the terminology that they're going to use in reference to, let's say, elevation. Elevation is typically going to be my opposite. So this plane, if it has an elevation of, like, let's say 3,500 feet, that is this length right here. Okay, has an elevation. Does that make sense? 3,500 feet off the ground, so it's a vertical length. If we say, you know, it is 7,000 feet from the airstrip. I'm going to use the airstrip as this point right here. We're 7,000 feet, okay, from the airstrip. My question might be, what is the straight line distance from the airplane to the airport, right? Which would be this length right here. Okay, now there's more than one way to do that, and it might give me this angle here and say the angle of depression is 23 degrees, right? And I can use that. Okay. Now, granted, you could probably still use Pythagorean theorem on a question like this. So there might be more than one way to solve it, but we're going to use our angles as much as we can. Okay? All right, you follow me so far? All right, I don't know that they really give you a whole lot. Let's see. Nope, that's it for that. All right, so let's look at some questions. If I have, let's see, we need less than 73, so evidently I've closed that out. Or didn't ever open it. Okay, 73, right? We did 71, 72, so we're at 73. Okay. Something along the line of a tree casts a shadow. Now, the handy thing about these is that we're pretty much drawing right triangles. A tree casts a shadow, but it's an angle of elevation question. Notice the angle of elevation of the sun is 30 degrees. So this is the way I want you to see this. Okay, here's my tree. It's a pretty good tree, right? Okay. I've got my sun. My sun is up here in the sky, right? And it's shooting a ray of light that's coming down to here. I've got a shadow that's coming across to here. This is forming a right angle. You follow me? Okay? So we've got a right angle here. So the angle of elevation, this is where people will make a mistake. All right? If I call these different things, like let's say we'll call that C, let's call this A, let's call this B. Which angle is my angle of elevation? B. Okay? Because it's from the ground going up. The sun is at an angle with the ground of 30 degrees. The mistake that people make is they make that 30 degrees angle A, and you're going to be wrong. Okay? Angle of elevation is always from the bottom looking up. All right? And if they give me the word elevation, that's the big clue. Okay? So go back to that first picture that we saw. Okay? The shadow is 26 meters long. So what line segment is that? CB. All right, so here's 26. Let's see, we want to find the height of the tree. I don't know the distance of AB, so can I use the Pythagorean theorem to find AC? No, so this is where we actually have to use our trigonometric functions. So we're looking for the height of the tree, x. Okay, so we're using a trigonometric function. The first thing I have to determine is which trig function am I using? Can anybody tell me? Tangent. Why tangent? Because I'm looking for opposite and I have adjacent. I'm going to use the two things that I have, or at least the one thing that I have with the one thing that I'm looking for, right? Because I'm not looking for AB, I'm not going to use cosine or sine because both of those use hypotenuse, and I don't need hypotenuse to solve this question. Does everybody follow why we're using tangent? Okay? So as we're writing this out, we're going to start with tangent. What goes next to my trig function? What's that? 30, my degree. Okay, what do I need to check before I do anything in my calculator? I need to make sure it's in degree mode because it's very often, too often does our calculator get switched back to radian mode. All right, so I'm going to set that equal to the ratio that tangent is. What is tangent? Anybody? Opposite over adjacent. What is opposite to angle 30 here? X. Okay, I'm hearing people whisper it. Okay, if you know it, feel confident enough to say it. All right, what is adjacent to my angle? What's that? 26. Okay, so if I want to solve this, if I want to solve x, what do I need to do here? Multiply both sides by 26. Good. So what I'm going to plug in my calculator is 26 tangent 30. Okay, that is going to be equal to x. What does x equal? Anybody tell me? I'll let you guys figure it out. What do you get? 15. 15. Okay, notice that that's C. Is this doable so far? Okay, good. Now, what would I have done if for whatever reason x had been on the bottom? Let's say this was AC was 26 and CB was x. I was looking for the length of the shadow. Okay, this is where it involves two steps, right? I would have multiplied by x, and I would have taken 26 and divided it by tangent 30, right? It would have been a second step. Okay? I just want you to be prepared for that because sometimes that happens. Okay, let's come down. All right, this is where I'm telling you that an eagle 300 feet in the air spots its prey on the ground, probably a cat, right? Deserving of death. You ever been in a house with a bunch of cats? It just smells bad. Okay, I just don't like cats, huh? I just don't like cats. Okay, this makes me a reasonable human being. Okay, are you demented? See, why do you throw that at me? Don't throw something back at me. All right, so let's start off with our picture here. We got our bird of prey, right? Okay, there's my eagle. Not too bad, right? Okay, well, look at what do I? Let's see. Let me ask: is this my triangle? Yes? No. What do I always? What should I always include with these? I should always include my line of sight, right? Okay, line of sight is always what with the ground? Parallel, right? It's always parallel with the ground. So his line of sight comes out like this, correct? Okay, he's going to look down on the cat like we all should look down on cats. Okay. I don't know what that is. That's terrible. Okay, let's try something else here. It looks more like a rabbit, but or whatever. Okay, it's going to die anyway. Okay, so it's seeing this cat. Okay, all right. So we're going to erase this because it's wrong. Okay, my angle of depression, again, should always be, my angle of depression should always be this upside down right triangle. Does this make sense? Okay. All right. Where does the 300 go? Let's go ahead and we'll label this. What line is my elevation, or what line is my 300? No, it's not AB, CB, right? Because he's 300 feet above the ground, correct? All right, so 300 is CB. All right, the angle of depression is 15 degrees. All right, that should be his sight. Okay, we would call that angle CAB, right? Okay, CAB. What is the horizontal distance between the eagle and its prey? Okay, horizontal distance should be a horizontal line, correct? All right, so what line is that? AC, so we're looking for this right there. Okay? All right, so we're going to look at what I have and what I'm looking for in relation to angle 15. All right, what is 300 to angle 15? Anybody? Is it opposite, adjacent, or hypotenuse? Opposite. What is x? Adjacent, because it's not hypotenuse, right? So which trig function am I using? Tangent. Okay. What am I writing next to tangent? 15 degrees equals opposite over adjacent, all right? So what goes on top? 300, opposite, right? I know that makes life tougher, all right, because what do I have to do? I have to multiply by x on both sides, right, which is giving me x tangent 15. Then I have to divide by tangent 15. So ultimately what I'm doing is I am taking 300 divided by tangent 15. Okay, so what does x equal in this? Perfect, thank you. 1,120 feet. Okay, 1,120 feet. Okay, we should all be working these out as much as we can, make sure that we know how to use our calculators to get these answers. Okay. Let's see, number 3, a pilot flying at an altitude of 1.8 kilometers sights the runway directly in front of her. Okay, angle of depression. It helps if I do this. Let's slide this over here a little bit. Okay? To the beginning of the runway is 31 degrees. The angle of depression to the end of the runway is 23 degrees. This is a tougher question, and you will see this question on a test. This, I'm going to try to draw out for you. I don't, if I've got a page in here, let me try this and move this over. Okay. All right. So we've got our pilot. Okay. Okay, with a line of sight, right? Okay, and we have down here a runway. Okay, runway is a big, long thing. Okay, now what we have here is that she has two different angles of depression. Okay, she has the line of sight to the beginning of the runway. She has a line of sight. She has a view or an angle of depression to the end of the runway. We're going to use that information to find out exactly how long the runway is. This right here. Okay? You follow me so far? All right, we're going to use this information to solve as much as we can. So let's look at what it says here. A person, oh gosh, this isn't even the same thing. Okay, well, let's see. Let me go back to our question here. See what I can do. Okay, we're at 1.8 kilometers, correct? All right, so let's fill that information in. 1.8 kilometers. That should go here and here, correct? So we're 1.8 kilometers up. That's a vertical height, right? All right, do you guys have the document? So can anybody tell me what is her angle of depression to the beginning of the runway? 31 degrees. So I'm going to make sure we see the difference of that. 31 degrees. And what is the angle of depression to the end of the runway? 23 degrees. Okay? So we're going to look and we're going to try to find the total distance of each. Okay? Now, if I find the total distance to the end of the runway and I subtract the distance that he is from the beginning of the runway, I'm going to be left with how long the runway actually is. Does that make sense? Okay. So let's do the whole runway first, or the distance to the end of the runway. Okay? So what that gives me is that I have opposite, I'm looking for adjacent. So what am I using again? Tangent. So I'm going to keep this in red. Okay, tangent what? 23 equals, what's opposite? 1.8 over x. Now, we should get good enough at this that we understand that if x is on the bottom, I'm going to take my numerator divided by my tangent 23, right? So what's 1.8 divided by tangent 23? What is it? .2. Okay. All right, so we have 4.2 kilometers. Okay, now we're going to do our blue one, okay, which is going to be tangent 31 equals 1.8 over x, or 1.8 divided by tangent 31. What did it come out to? 2.9. So what we're going to do is we're going to take 4.2 minus 2.9. What does it come out to? 1.3 kilometers. That's how long the runway is. And again, this question actually, well, let me see. Let me get back to that. I want to say, if I come down here, 3, the answer is A. This comes down to a rounding error, and I don't like that 1.2 and 1.3 are so close to each other. Your answer should be 1.2. Again, I think that's because we rounded up. We should have left it. Okay? So we should get 1.2 kilometers there. All right. Let's see. What time did we get out of here? 31. I think, and I'm going to go ahead and assign the assignment. I'm not even necessarily going to record questions 4 and 5 because at this point we've done enough angle of elevation, enough angle of depression for you guys to get the concept, right? Yes? Head shaking up and down? Okay.